Lesson 5-7, Complex Fractions. The objective here is to simplify complex fractions. 2 steps. First, find an LCD for all fractions involved. Second, multiply numerator and denominator by the LCD and simplify the result. Example 1 is to simplify the complex fraction below. So we'll take a look at the denominators here. We have 6, we have 3, we have 5, and we have 10. We'll look for a common denominator amongst all of them. Since these are all numbers, we can just realize right away that the common denominator is 30. So what we'll do is multiply the numerator and denominator by 30 both. We're going to see that we have to distribute this 30 to every term. When doing so, we end up getting 30x over 6 minus 30x over 3 all over 30x over 5 minus 210 over 10. And what we'll see is that coincidentally or conveniently, these numbers all happen to reduce nicely because we found the common denominator of all of the denominators themselves. So we end up getting 5x minus 10x all over 6x minus 21. Now, simplifying further, the numerator becomes negative 5x all over 6x minus 21. Example 2 says to simplify the complex fraction below, but here we're going to notice that our denominators are made up of variables also, not just numerical values. So here we have to think about the fact that when we have variables, to find a common denominator, it was always the question of what is missing. Like what's missing in all of the denominators. So what I want to do here is realize that this denominator is missing x plus 5. This one is missing x minus 3. This one is missing x minus 3. Well, if I had all those there in the denominators and I had them respectively in their numerators as well, if I multiply the top and bottom by all of those individually, we'd have a common denominator amongst all of our fractions. Well, that's the same thing as just multiplying by the common denominator. So it turns out that this is the common denominator. So the common denominator is the quantity x plus 5 times the quantity x minus 3. So let's take our original fraction now and go ahead and multiply by those common denominator. So we have 3 over x plus 5. This is going to be times x minus 3, x plus 5, all over 2 over x minus 3, plus 1 over x plus 5, and again multiplied by x minus 3 times x plus 5. Now what we're going to notice here is when we multiply this by this whole thing, the x plus 5's cancel, leaving behind in here 3, right, from this, and the x minus 3 here. In the denominator, though, we have to realize that this entire fraction here is going to end up getting distributed to both of these terms. When I distribute it to the first entity, this has x minus 3 in the denominator. So that x minus 3 cancels with this x minus 3 right here, leaving behind the 2 and the x plus 5. So the first term in the denominator is 2 parentheses x plus 5. The second term in the denominator, we're realizing here that this x plus 5 is going to cancel with this x plus 5 when this gets distributed, the whole thing, leaving behind this 1 and this x minus 3 here. So this is going to be plus 1 times the quantity x minus 3. Now if we take a look here at this fraction here, we can distribute the numerator, distribute all this, and come up with a simplified fraction. That simplified fraction ends up becoming 3x minus 9 all over 2x plus 10 plus 1x minus 3. Simplifying the denominator, in this case, that's an arrow there, we're going to get 3x minus 9 all over 3x plus 7. Make sure you do not make the common mistake here and try and cancel these 3x's because they're not factors. These are add-ins. These are add-ins. So this term and this term is an add-in. 3 is a factor, x is a factor, but 3x is not a factor, so these 3x's cannot cancel. Example 3 says to simplify the complex fraction, and here we're going to see that one of our denominators has just a 1 in it as a denominator, right? There's just a 1 in this denominator. It's 1 over 1. This is 1 over 1. But this denominator is x, this is x, this denominator is x squared. So it looks like x squared is going to be our common denominator. So we multiply the top and bottom both by x squared. Distributing the x squared to the top, we're going to see here, we get just x squared plus, now this is 3x, the 3 over x times x squared. So that x cancels one of these, leaving behind a 3x. And then this x squared gets multiplied again by this here, making this x squared cancel with this x squared, leaving behind just a 2. All over x squared plus 2x. Now if I could factor here, it would be helpful, and it looks like I can. The numerator is x plus 1 times the quantity x plus 2. The denominator, we factor out a GCF of x, leaving behind x plus 2. Canceling the x plus 2's gives us a final answer in this problem of x plus 1 over x. Now, if you'd like to, you could reduce this further by dividing everything by that x, and this x over x becomes 1, and this 1 over x just becomes 1 over x. So you could write your answer like that, or you could have left it like this, x plus 1 over x. Depending on which scenario you're looking at, some are more useful than others. And then also for an SAT test, you have to be able to manipulate your answer. Example 4. Here we have negative exponents. We have to remember that negative exponents really mean 1 over the positive exponent. So r to the negative third is really 1 over r to the third. S to the negative third is really 1 over s to the third. All over 1 over r plus 1 over s. So it looks like our common denominators here are going to be r cubed, s cubed, because I can see here that everything has an r in it, or an s in it, or everything has an r cubed, or an s cubed. So let's make our common denominator r cubed, s cubed. So we multiply by r cubed, s cubed in the top and bottom here. This gets distributed to both of these. This gets distributed to both of these. Now we're going to go down and we're going to simplify. We're going to see that when we multiply this out, this r cubed cancels with this r cubed, leaving behind s cubed. This s cubed cancels with this s cubed, leaving behind the r cubed. So that's what your numerator becomes. Your denominator here, this r cancels with one of these r cubed, leaving behind r squared, and still this s cubed. And then the opposite happens here. One of these s's cancels with this s, leaving behind s squared and this r cubed. Now what we'll notice next is the numerator is the sum of cubes. So we have to factor this into sum of cubes. And if you remember sum of cubes, we get s plus r times the quantity s squared minus sr plus r squared. And in the denominator, we're going to see that we can factor out r squared, s squared out of both terms, leaving behind s plus r. And now we'll see that the s plus r on the top and the bottom both cancel out, leaving as a final answer s squared minus sr plus r squared all over r squared s squared. And example 5 says to express f of x as a single simplified fraction. So we're taking f of x and putting it into f of x. So that means that this quantity, f of x, is going to go in for x here and for it here. So the quantity x over x plus 1 goes in the numerator here for x, but it also goes in down here. Remember, that's how you evaluate a composition of a function. You plug in the inner term, f of x, into the outer term. So this is our fraction now. And what we'll notice is that x plus 1 is our common denominator. So we'll multiply by x plus 1 over x plus 1. Multiplying here, these cancel. And that leaves behind just simply an x in the numerator. In the denominator, though, this has to get distributed here, which leaves behind an x. But then when it gets multiplied here, we get x plus 1. So what we get as a result here is simply x over 2x plus 1.